Hello, my name is John Bigley and I'm starting us off on the virtual tour of our plant in Perth. In this first part of the tour, we'll be having a brief walkthrough just to give you a feel for the place. But after that, David Kilpatrick, our R&D Quality and Innovation Director and one of the co-founders of the business, will be giving you a much more detailed view of the process. I joined Zipform Packaging as CEO nearly 3 years ago, and after 30 odd years in metal packaging, I have really enjoyed working with another packaging substrate and one with a great sustainability story. Our composite packs have over 60% recycled content, already beating APCO's 2025 national packaging target for recycled content, and the packs contain around 92% fibre. Why do I call it a pack, not a can? Well, to me, given my history, I think of a can having a metal end, which traditional composite cans do, such as the Pringles can. Our packs have a paper bottom, hence the differentiation. We even have a swear box in our boardroom where you have to put $10 in a pack for every use of the word can. By the same token, I don't like calling the printed layer a label, as a label to me is a post-process applied bit of material. Our printed layer is an integral part of the construction of the pack, as you'll see in the video. The Perth plant is the heart of the business, where 9 out of the 12 of us are based. The other 3 of us, the business development team, are in Melbourne. Why Perth? Well, that's where the 2 co-founders, David Kilpatrick and Eddie Pahor, started the business in 2010. Their vision is as true today as it was then insofar as bringing more fibre-based packaging to the market. The production line that you're seeing today has had a few iterations, and it's the only line of its kind in this region. As you can see, the plant operates in a clean room environment, and the process itself is very clean. It certainly impressed me when I joined, given my food can and infant formula can history. This cleanliness, alongside our rigorous quality systems, has meant that we have achieved BRC AA accreditation. Aside from that, we were the first Australian packaging business to be awarded Trusted Trader status by the Australian Border Force, a recognition of our robust supply chain processes. In 2018, we joined APCO. Whilst we were not a brand owner, we felt it was important to engage with our customers through APCO. Aside from the discipline of the annual report and action plan, we also use the prep tool with customers to demonstrate the recyclability of our packs. And back to the plant. You can see that the process is highly automated. The 3 tool shapes or footprints that we currently offer, and certainly we've got more in the pipeline, can be produced in any height between 46mm and 230mm, meaning that changeovers need to be, and indeed are, relatively straightforward. This means that customers have a lot of flexibility in pack design without having to worry about expensive new moulds. In addition, all printing technologies can be adopted for producing the printed layer at our third-party printers. 2 of the footprints are circular, a 73mm and 99mm diameter, and a third is a non-round shape, which is extremely attractive, easy to hold, and offers inbound and outbound logistics benefits. The line will be operating on a 2-shift basis later this year, and across the 3 shifts the capacity is around 20 million packs per annum. Of course, it's our ambition to grow and have other lines in other geographies. This innovative forming process, producing a hermetically sealed pack, means that our potential customer base is very broad. We even have a specification which is dual ovenable. We see applications in dairy, deli, nutraceuticals, milk powders, nutritional powders, soups and sauces, ready meals, cereals and beverages. David Kilpatrick's brain is continually working on developing our offering, whether it be through innovative use of components like for our R-pump innovation, or material developments to utilise the latest technology of coated materials, increasing the content even above today's heady heights of 90% plus. I think that's a good segue now to hand on to David and a detailed walkthrough of the manufacturing process. Over to you, David.
Thanks, John. Normally when I'm doing these tours I have to talk over the top of the sound of the production line itself, so it's kind of nice that on this occasion I can pre-record the voiceover and include it in your virtual tour of the production facility. This first piece of vision we're looking at shows the unwinds where the raw material is loaded and then delivered to the process. So from left to right we've got the liner material, which comprises on the surface that we can see the bleach craft, In behind that is a thin layer of aluminium foil, and in behind that is a layer of kind of a hard polyethylene, and that liner material is critical to the functional attributes that we're looking to achieve in the pack, both in terms of hermetic sealing and barrier. So the foil is obviously included as a barrier material, and the hard PE is available to the process for achieving an hermetic seal. Next, we have 2 reels of coreboard, recycled fibre, which provides, or in combination with the lamination process itself, provides the incredible structure and strength of the pack, and enables us to achieve a recycled content of 60 to 70%. And finally, we have the label layer, which John has already indicated we prefer not to refer to as a label per se, because it's an integral part of the pack, and that's the print is applied to a typically 100 GSM FSC virgin graph paper. The inline lamination capability is a key feature of the process, and enables us to customise structures according to the specific functional and other requirements for an application that a customer might have. So we use a standard suite of materials and put them together in different combinations to achieve those different outcomes or attributes. Here we're continuously sealing the liner material, so utilising the hard PE layer that I described earlier, and essentially sound waves to generate heat to achieve the temperatures to securely bond those layers of PE. And you can see also that the other layers of the pack are at this point open, so we seal that liner first, and you can see 2 layers of coreboard and then the label layer on the outside. And the other thing to highlight there is that all of those joins are staggered, so that they don't constitute a weak point in the pack or any kind of disturbance of the otherwise smooth surface of the pack. And now you can see the body making, so the belts that are pulling the webs through the process, and completing the process of setting the fibre in particular into the new required shape. You can see in the front of that shot the little blue box, which is the photoelectric cell, which is registering the eye mark and controlling the position and movement of the cutting frame. So because the web is moving continuously and we can't have any relative motion between the cutting blades and the materials that we're cutting, we need to move those blades at the same speed and in the same position relative to the eye mark, which is included as part of our print spec. So now we've got those individual packs cut. We're just going to separate them one at a time, and they then go through this pretty nifty kind of stander upper. It's a very technical term for something that stands something up. But you'll see the packs there spinning on that conveyor and then going through the red box, which is where they get stood up into the correct position. That's just with some side belts that are travelling faster than the bottom belt and a stop position to force them up. We then have the packs travelling up and down these conveyors, which makes for great video. It does have purpose in the sense that we put a lot of moisture into the walls of those packs, and now we're using the temperature controlled and humidity controlled environment to remove some of that moisture and make the packs a little bit stronger for the next process. So there's an accumulation table there to provide a buffer between the body making and the closing operations, and then an elevator because we gravity feed the packs into the closing machine. And so, we have to get them up to the right height in order to do that. And here they are coming down into it's a multi-pack and being loaded onto double tool sets. There are 6 operations involved here, and a total cycle time for closing a pack is about 1 second. And so we need to be able to do 2 packs at a time in order to match the speed on the body maker of between 100 and 120 packs per minute. So in this first bit of slow-mo, you can see the top curl being formed. Obviously the tooling again is critical to ensure that the correct formation is achieved. The cutting length is critical to ensuring that the right amount of material is presented to the curling tool. And that means that we have an upper surface of PE to seal to when it comes to applying a membrane lid, for example. The profile of that curl gives us a really good connection for overcaps and reclose functionality. So the rest of this process involves die cutting and inserting and welding the paper bottom material. We then do an inward curl, so turn the body of the pack inwards and then flatten that curl so that we get a nice neat finish to the bottom of the pack. And now we're removing those packs from the tool and delivering to the inspection process. So the packs are now hitting the conveyor, ready for palletising. And now the very clever robot that picks pallets, picks layer pads, and of course picks the packs and positions the packs so as to ensure we achieve the maximum volumetric efficiency. John mentioned before that we can do non-round shapes, and there are some gains to be had from that in terms of volumetric efficiency on the inward journey to our customers and on the journey from our customers to their distribution channels, supermarkets, whatever. Then we'll completely and securely wrap and then reinforce those pallets for the onward journey to the customer. And that's what the process looks like. It's pretty amazing, and we always enjoy showing it to people.
David and John. As the team have mentioned, one of the great benefits of our linear draw composite process at Zipform Packaging is the ability to utilise a range of print technologies that best suit the pack requirements as we're printing on a typically 100 GSM label stock in roll form. With the outer layer traditionally being made up of a standard label paper, this can be printed through either offset, flexo, or even a digital process within a network of printing suppliers across the country. The real benefit of this, however, is the flexibility this enables brand owners of all sizes. From digital printing, which provides the opportunity for lower rung lengths for promotional or startup volumes, to flexographic or offset for larger volumes with established requirements. The flexibility built into the process also allows us to switch between the designs and print lengths with relative ease. Within each of the print processes, there's an extensive list of embellishments available to even the most ambitious designers, including a full range of varnish options, which can be used to either highlight your branding or to generate a textured feel on pack. To add an even more premium feel to your packs, foil stamping is available across the range. That concludes our tour for today. On behalf of all of us at Zipform Packaging, I'd like to thank you for visiting us today, albeit virtually, and we hope that someday in the near future we'll be able to host you in person at one of our manufacturing facilities. Bye for now.